Welcome everyone to another interesting DSA problem, binary tree post-order traversal. I would recommend go back and understand the pre-order and in-order traversal for the binary tree, because to explain this particular problem I will be using the ideas which is borrowed from in-order traversal as well as pre-order traversal. So let's try to understand the problem statement of this thing. So the core idea of the post order traversal is that left then followed by right then followed by the root. For example, for a given root we would be considering the left part, then we would be considering the right part, then only we would be considering the root part. If the root is something like 2, then first we would be considering this, then only we will be coming here. For 5, first we will be considering this, then this, like this. So in that case, how the result list would be coming up, let's see. So first the left part with respect to this root, here again this left, so 4 comes, so first 4 comes, then the right part which also have a left part, then 6 will come, then 7 will come, then 5 will come, then 2 would come, then this particular right part. So here this 9 will come, then 8 will come, then 3 will come, then 1 will come. This is how the post order traversal is going to happen. So here the core idea is first the left, then the right part, then the root part. So how we can code it? So the natural way, the recursive method, we can just borrow from the in order. So this is the in order code. What we need to do here, in order idea is something like left, root, then right. This is for in order. We are solving it for post order. Post order is left, right, and then root. So only thing which we need to change is that whatever be the relative order of execution here, okay, we just need to change it left, right, then followed by the root. And also we should change this naming, but it doesn't matter, just understand that this naming has also to be changed for the better understanding of the code and everything. So what we just need to do here is that we just need to swap these two lines. So let's try to swap it. This line, the right, okay, this would be coming, here, yes. Now this will work. So what is the time complexity and space complexity? Time complexity order of n, space complexity is the recursive stack space, which is n, so that will be order of n. And how can we solve iteratively? So just go back to the pre-order traversal and understand this particular code. I hope you already understood by now what is pre-order. So I told you I am going to borrow idea from in order and pre-order. So pre-order idea is nothing but left, then followed by, pre-order idea is nothing but root comes first, then comes left, then comes right. So this particular code which we have given and understood in the last video is all about the pre-order, and we need post order. Let's try to make logic here. The post order is nothing but left, right, then comes root. So what we can do, we can make a simple change in the pre-order. Instead of left after right, we can make right then left by changing two lines. These two lines I am going to shadow here. Okay, these two lines we've got interchanged. The pre-order sequence become root, then right, then left. The stack space is going to save it like that. So first let me make it like that. Okay, then I need some very good space here. First let me make it this a bit smaller. Okay. If I swap these two pieces of code, one above the other, what is going to happen here? The pre-order sequence, which we have already discussed, this will become root, then right, then left. And right now this particular code represent root, then comes right, then comes left. So this is how the result going to append. And see, what if we reverse it? If we reverse it, this is nothing but left. If we reverse it, this is nothing but first the left comes, then the right comes, then the root comes. That is nothing but what we needed, the post order thing. So this is a simple reorganization of pre-order. First we just need to check, we need to swap two different block of codes. Then we just need to return whatever the result we just got. We just need to return by reversing it. So just add this simple line of reversing the result. So that's it. There is nothing more to be done. Just understand one particular traversal method, and connecting with that traversal method we can understand the other thing. So what is the time complexity? Here time complexity is order of n, space complexity is also order of n. And I hope you understood this problem of binary tree post order traversal, and thank you for listening.